All right, for number 14, we're trying to simplify. We have 2 squared 2 divided by 3 squared 25. In this example, we can simplify the square root of 25 as 5. So this looks like 2 square root 2 divided by 3 times 5, or 2 square root 2 over 15. In number 15, I can write this as the square root of 15, which doesn't have perfect squares, and the square root of 9 times 3, or the square root of 15 divided by the square root of 9 times the square root of 3. This is going to look like the square root of 15 divided by 3 square root 3. Now here, I can keep 3 in the denominator, but I can divide the square root of 15 by 3. One of the properties with radicals is that the radical of a over the radical of b is equal to the radical of the quotient here. So if I've got the square root of 15 divided by the square root of 3, this looks like 1 over 3 times the square root of 15 over 3. Or 1 over 3 times the square root of 5. For a final answer of 5, the square root of 5 over 3. When we talk about adding like terms for some expression like 3x plus 4y minus 10 plus 6y, the like terms have the same variable and to the same degree. When we talk about like radicals, they need to have the same index. So in both these examples for 16 and 17, they're both square roots, so that works. And they have to have the same radicand, or the same number that's inside the radical. So for the square root of 6, this can't be simplified anymore. But for the square root of 8, I can simplify the square root of 8 as the square root of 4 times the square root of 2, or 2 square root 2. 2 times the square root of 2. So if I have the original 2 on the outside, and I'm multiplying by 2 square root 2, this looks like 4 square root 2 for 2 square root 8. In that next term, I was subtracting the square root of 24. If I wanted to simplify the square root of 24, I would say it's 4 times 6, the square root of 4 times the square root of 6. So I'm taking away 2 square root 6. Now I already have negative 3 square root 6. And I'm trying to show with the colors that if I'm going to try to combine them, it's negative 3 square root 6 minus 2 square root 6. That's going to be negative 5 square root 6. And I'm adding 4 square root 2. For number 17, there probably aren't going to be as many examples that combine them right away. But if they're both in the square root of 45, I can say negative 3 square root 45 plus 2 square root 45 is negative 1, or negative square root 45. And I'm adding 2 square root 6. Now I need to simplify the square root of 45, which when I think about numbers that multiply to 45, 1 and 45, 3 and 15, 5 and 9, then I've exhausted all the options. The only example here that I have for a perfect square is going to be 5 and 9, so it's like negative the square root of 9 times 5, or negative square root of 9 times square root of 5. So this becomes negative 3 square root 5 plus 2 square root 6. In number 18, I'm multiplying. I need to distribute the square root of 2 times the square root of 3 plus the square root of 2 times 3. I would write this like the square root of 6 plus 3 square root of 2. Now, in 19, they're asking us to rationalize the denominator. To be able to do this, I need to multiply by the conjugate. So when we look at the conjugate, we're going to keep the two terms the same. In this case, I'm going to keep 5 and the square root of 5. Sorry, my dogs just grabbed something they shouldn't. So if it's 5 and take away the square root 5, then I'm going to rewrite this, or multiply both the numerator and the denominator by 5 plus the square root of 5. Here is the original 5 minus the square root of 5. And when I multiply by 5 plus the square root of 5, 5 times 5 is 25. I'm adding 5 square root 5. I'm taking away 5 square root 5. And then I'm taking away the square root of 5 times the square root of 5, which is the square root of 25. Or this can be thought of as just 5. So it's like 25 minus 5. The terms here, the adding and subtracting of 5 square root 5, they cancel, so this whole thing in the denominator is going to be equal to 20. So my denominator is 20. When I multiply 2 times 5, I get 10 plus, and then it's 2 square root 5. Technically, each term is divisible by 2, so a final answer would look like 5 plus the square root of 5 over 10. Some people make this jump that when we multiply by the conjugate, this is like that difference of perfect squares, a plus b times a minus b. Some people make the jump that this is going to be a squared, take away b squared. You see this with like x minus 3 times x plus 3. This is going to be x squared minus 3x plus 3x minus 9, or just x squared minus 9. It's okay if we don't memorize that fact. You can distribute the way that we've done before. Some people use FOIL, some people use the box method. For number 20, they're asking us to solve the equation. What we talked about in class was that we needed to isolate the radical the same way you would isolate the variable. So if I saw this example here and I'm multiplying 2 times the square root of 12 minus b, I would divide both sides by 2 and get 2 equal to the square root of 12 minus b. At this point, I need to raise each side of the equation to the power of the index. What I mean by that is that if this is the square root, then I am squaring both sides of the equation. 4 is equal to 12 minus b. Now we solve for b. I would subtract 12. Negative 8 is equal to negative b. I'm going to divide by negative 1 to get b equals 8. If I were to check, this would look like 4 equals 2 times the square root of 12 minus 8, or 4 equals 2 square root 4. 4 is equal to 2 times 2, where I get 4 equals 4. So that was an example where we were multiplying the radical by a constant. In this next one, I have the square root of n plus 8 minus 3 is equal to 2. So if I'm trying to isolate the variable, I would need to add 3 on both sides to get the square root of n plus 8 equal to 5. At this point, I would need to square both sides, and I get n plus 8 is equal to 25. After this, I subtract 8 on both sides of the equation. I get n is equal to 17. The square root of 17 plus 8 minus 3 should be equal to 2. The square root of 25 minus 3 is equal to 2. 5 minus 3 is equal to 2. 2 equals 2. And so that is the last question on the test. I don't know why I forgot. I didn't put an answer for number 9. If you have any questions for it, let me know. You guys will be able to use calculators on it. Again, it'll be on Thursday. I won't be in on the Tuesday. And email me if you have any questions.